Confluential derivative process. Here we're going to see that there's a slightly different aspect in the confluential derivative process. So we already know we have an origin process, a source process that can deviate to a destination. But let's say our destination is common to a lot of sources, a lot of origins. So here we have process A1, A2, and A3. These are causal processes, and they're all managed, all the data that we're generating here is managed in one unique destination confluential derivative process. So once the derivative process is created, it can receive different lines created from different causal processes that are deviated to an intermediate message event of this single process, which has been previously created. So the first process that needs to be created would be this one here. Okay, we know that the lines are created here, or the data is created in these processes, but this process must be created in order for this deviation to take place. Let's imagine a scenario where process B was not created. Process A starts, tries to deviate. Obviously, it's not going to find the EM. It's not going to find the flow stopped here. So it's going to give us a message telling us we weren't able to deviate because there's no flow in the destination event. We don't want this to happen. So in this scenario that we're trying to explain, confluential derivative processes, we always need the derivative process to start. Once it started and once the flow has stopped here in the intermediate message event, then these processes could trigger a deviation to this intermediate message event. Okay? This is another concept that it's also important in order to understand the final scenario that we're going to see today. Besides, you guys are going to build an exercise based on all of this information. It is a complex exercise. It is also the advanced course, and we've already finished with this block. We've finished the advanced course. So obviously, you guys are expected to be able to solve these type of scenarios. Let's imagine here an example for confluential derivative process. We have, let's say, several causal processes where each one of these different people are going to make a tax declaration, for example. So let's say I need to declare my taxes, so I trigger a process. And there's someone else that also needs to declare their taxes, so they trigger another process. So all the information is being generated in these causal processes, and they need to be inspected by a tax office committee. So this committee has to periodically meet up to define in just one session which declarations need to be inspected. So they're all deviated to this confluential process. And maybe in this confluential process, there's hundreds or thousands of hundreds of lines because there's a lot of people in the country that are doing these tax declarations. So they all enter, and maybe in this confluential derivative processes, maybe there's business rules, there's algorithms, or there's even people who are going to decide which lines are going to require an inspection. So let's say the ones that don't require an inspection can be deviated back to the causal processes, but the ones that do require an inspection, they need to be treated in this derivative process. Once they're treated, or once the inspection took place, then we could also send these lines back to the causal processes. So this is just an example of how we could use these confluential derivative processes in order to process lines that are being generated in other processes. Here we can see different types of confluential derivative processes with different examples. Here, let's say we have a line inlet. We generate a batch, and once we create a batch, we have to process that batch. Okay, so the process is going to wait for a sufficient number of lines or for a deadline or a condition or something to be met in order to process all the batch. So let's say we have tax declarations that are entering this process continuously. So maybe the tax declarations could be processed or could be submitted until June. So we're creating a huge batch until the month of June. After we have this large batch, we need to evaluate which declarations actually need to be inspected. And maybe the lines that are going to be inspected also depend on the total amount of lines that have entered that year. So we create a batch in June. We say, okay, this batch has already been created. We're going to process the batch. And the lines can all enter the different activities that need to process these different batches. So in this example, here we have an example that says the processes wait for a sufficient number of lines for a deadline or condition to be met in order to process the whole batch. For example, a printing process does not start until the newspaper has been edited. So once the newspaper has been edited, the batch has been created, and then the printer can start printing. And here we have another example where we want to give the lines a continuous treatment. We never stop. So let's say the lines are managed in a derivative process that's going to process the items, in this case pencils, all the time. For example, in a factory that runs 24/7. So basically, every time we receive the wood, it enters the process and the process starts managing or giving the treatment to the wood until it turns into a pencil. And this never stops, it's always running. So let's say we have confluential derivative processes that can work in batches. So we create a batch and then we treat it. And in other scenarios, we want this to be continuous. So it's going to be always open, always processing lines.